Good. Okay, let's do it. So again, even before we get to the solution, right? Looking at this, I mean, we have 5 times x and 3 times x. I mean, those numbers aren't terrible to work with, right? You know, they're pretty simple. I mean, you theoretically, I mean, if you add these alone, x is not going to vanish. But if we look at here at negative y and 2y, well, here the coefficient of y is 1. I mean, I know we're subtracting it, but that's a lot easier to work with, you know, negative 1 and 2 than 5 and 3. So because these coefficients are easier to work with, let's try eliminating y. I mean, we can do that because we can just multiply the first equation by 2. And that's what I do. So if I multiply the first equation by 2, right? And then if we were to add, the y's would cancel. So let's do that. We have 2 times 5x minus y equals 2 times 5, right? So 10 times x minus 2 times y, we multiply by 2. That's equal to 2 times 5, which is 10. Right? So we have this new first equation, and we have this system to solve. But this is nice because we can just add the equations now. And if we now add them, the y's go bye-bye. So we add the equations. When we do, we get 13x. The y's are gone. 10 and 42 becomes 52. Okay, there was a mistake in here when I did this with my last class, but I think I fixed it. So hopefully there's no others. So we have 13x is 52, right? Again, that's what we just got by adding. So from here, right, we get 13x is 52. We divide by 13, as you can see, because we want to get x. Excuse me. So again, we really just have one equation, one unknown. The unknown is x. We divide both sides by 13, right? And we get x is 52 over 13, which is 4. So we know x equals 4, right? So the hard part is done. We have to get the other variable. That's okay. What do? We take x and plug it into either equation in the original system. So I'm plugging it into this one, which is the first equation, as we can see. Plugging it in, right, for x, then we can figure out what y is. So we have x is 4, so that becomes 20. So we have 20 minus y is 5. So we solve for y. Subtract 20 from each side. We get negative y is negative 15, right? Divide both sides by negative 1 because we want y. We don't want negative y. But we get y is 15, and the only solution is this, as we can see. So we have 415 is the only solution. Good. Okay. Any questions on this? Okay, so I did prepare some backup examples. So let's go through the first one at least. And even before we dive right in, right? For the first one, if we want to eliminate a variable, so for the first equation, we have 8x here, right? Minus 6y is minus 20. So can we eliminate x? Well, if we just added, the answer is no, right? However, if I take this equation and multiply it by 2, right? What happens? Well, the 8x turns into 16x. And if we add that with negative 16, that is going to, the x will then vanish. So we can't, so if we add it initially, x is not going to go away. Neither is y. But I can multiply 8x by 2. That is, I can multiply the first equation by 2. And if I do that, that will kill off x after I add. And that's what I'm doing here. I'm just trying to illustrate why I'm multiplying the first equation by 2. I mean, it's not the only thing you can do to eliminate a variable. I mean, you really could, for instance, multiply the second equation by a half. I mean, that will introduce fractions for y, which makes it a little bit harder, but we can do this instead. We could just multiply the first equation by 2. Doing so, we get this, which is 16x minus 12y, which is 2 times negative 20, which is negative 40. Now we can take this equation and add it to the second, as you can see. Adding, x is gone, right? Here we have negative 12y plus 7y. That becomes negative 5y. Adding these two, we get negative 10. So we want to get y. Okay, well, we have negative 5y is negative 10. That's cool. So what do we do next? Well, we can just divide both sides by negative 5 to get 2. So we get y equals 2. Y equals 2. Now that we have y, can we get x? Yeah, we just take that y and plug it back in to either one of the two equations. Namely, we have 8x minus, so what I did here was I used the first equation. You could use the second. I'm using the first, mostly because the coefficients are smaller. So we have 8x minus 6y, 6 times 2 is negative 20. So we have 8x minus 12 is negative 20, right? We add 12 to each side. As you can see, we get 8x equals minus 8. You know, once we add 12 to each side, right? Remember, we want to isolate x. So 8x is negative 8. And of course, we divide by 8, we get x is negative 1. So we get negative 1, 2. That's the only solution. Okay, so now for the second backup example, I'm not sure if I did it with the other class. Let me just say this though. I'm not going to be able to finish it all, but looking at this system, right? Well, we want to somehow kill off a variable when we add. Well, I could multiply the second equation by 6, right? Then I can add it to the first. And if I do that, x will go away because you'll have negative 6x, 6 times x. When we add it, that kills off the x. That's what I'm doing here. I mean, for time consideration, I'm not going to be able to finish this example. The third one is a little bit tricky. What I'm thinking is after break, I'll probably just do more examples of this. So at least the Monday after break. All right. So let me stop recording.